This is the homework for 384, 385, and 386. For 384, I needed to draw figure 0 and figure 4 for the pattern shown. I saw the pattern as horizontal tiles and vertical tiles. For figure 1, I saw that there were 3 horizontal tiles. Figure 2 had 4, figure 3 had 5, and I noticed it was increasing by 1 each time. I also noticed that it was just the figure number plus 2. 3 plus 2 is 5. 4 plus 2 is 6. 0 plus 2 is 2. For the vertical tiles, I noticed that it was just the figure number. Figure 1 had 1, figure 3 had 3, figure 4 had 4, so figure 0 would have 0. I then had to show the tile pattern in a table. I have the figure number and the total number of tiles. And the total number of tiles were increasing at a constant rate. For every figure number, it increased by 2 tiles. I then had to write the rule for it, and I noticed for figure 0, I had 2 tiles. So when x is 0, y would equal 2, the total number of tiles. And that's also my y-intercept when x is 0. And I knew that the rate was increasing by 2 for every 1 on the x. So I had a rate of change of 2 times x. Next, I graphed the table, and I plotted the points. 0 on the x, 2 on the y. For figure 1, 4 tiles, 2, 6 tiles. One important thing when you're graphing is to make sure you scale it correctly. If you look, I scaled all the way out to figure 10. And I didn't really need to, because in my table, I only went to figure 4. So if I were to redo this one, to scale it correctly, I would have spread it out and had this figure 1, 2, 3, 4. You want to maximize your graph. Is this graph discrete or continuous? It's discrete because you couldn't have a half of a figure or a half of a tile. So you do not connect the points. For part B, figure 5 would be at 5, 2. And there's a couple of ways you can do that. You can look at figure 5 and go up on the graph and see that it would be here at 5, 2. Or you could plug it into the equation. If x equals 5, 2 times 5 is 10, plus 2 is 12. In problem 385, we needed to use the graph to complete the table. So the points were already plotted on the graph. And for the first point was -1 on the x, -1, -2, -3 on the y. -1, -3. I like to think of them as hops. Quite often students will mistakenly say this is, start here and say -1, -2, -3. But think of it as hopping. 1 negative hop on the x, -1 hop on the y, -2 hops on the y, -3 hops on the y. The next point is 0 on the x. We're not going anywhere on the x-axis. And -1 on the y. 1 on the x, +1 on the y. +2 on the x, +3 on the y, and +3 on the x, positive 5 on the y. To come up with the rule, I first started with the y-intercept, which is negative 1. 0 on the x, negative 1 on the y, which gives us that. Then we have to find the rate of change. And the rate of change, 2 on the y, 1 on the x. Or we can also look here in the table. How did we go, what did we do to x to get y? Well, if we multiply it by 2, we'll do a positive value. 2 times 2 is 4, and then we have to subtract 1. 2 times 0 is 0, and subtract 1. And that's what we have here. In problem 386, we needed to find the area and circumference of a circle with a diameter of 15 centimeters. Well, you could have referred to the math notes in your book to refresh yourself on area and circumference of a circle. Circumference is the distance around the circle. Diameter, distance across, and radius is from the center point out to the edge of the circle. The way I remember diameter is if you go across, creates the letter D. D for diameter. And I remembered radius by standing in the middle and shooting a ray out to the edge. Radius. So remember, area of a circle is the radius squared times pi. Or you could write it, area equals pi times radius squared. The way I remembered this is apple, pies are squared. Apple for area, pi, r for radius squared. So we know that the diameter is 15. Well, if the diameter is 15, we need to find the radius. Half of 15 is 7.5. So I plugged in 7.5. And now I go ahead and solve the equation. And I'm going to approximate pi as 3.14. And 7.5 squared is 56 and 25/100ths. I turned the equal sign into an approximate value. It's a squiggly equal sign because pi is approximately 3.14. And now we have 3.14 multiplied by 56 and 25/100ths equals 176 and 6/10 centimeters squared. Remember, area is the inside. How many square units would that be? And if the diameter is 15, there would be 176 and 6/10 of those squares in there. For the circumference is pi times diameter. So we have C equals pi times 15. Pi is approximately 3.14 multiplied by 15. And the circumference, or the distance around the circle, is approximately 47 and 1/10 centimeters.